Hey everyone, welcome back. I know a lot of you are really into robotics, so I'm excited to share something pretty cool today. We're going to be taking a deep dive into Fleet2D. It's a brand new simulator from Amazon Science, specifically for home robotics. And get this, it's open source, so you can actually play around with it yourself later.
That's right. And what makes Fleet2D really interesting is that it tackles a problem that's been a real pain for researchers and developers: long-term simulation in home environments. Think about it. Homes are constantly changing, right? Kids leave toys around, furniture gets rearranged, and our daily routines evolve over time. Traditional simulators are great for short tasks, but they really struggle with these long-term dynamic scenarios.
So are you saying we need a simulator that can handle, like, the chaos of a real home?
Exactly. Imagine you're designing a robot that learns your cleaning preferences or adapts to your family's schedule. To really test those behaviors, you need a simulator that can run for weeks or even months of simulated time. And it needs to account for all those little changes that happen in a real home. Okay, that makes sense. But testing in real time, that would just take forever.
You got it. That's where Fleet2D comes in. It's designed to be incredibly fast, allowing you to simulate months of robot activity in just a few minutes. This speed opens up a whole new world of possibilities for developers.
Okay, I'm hooked. But how does it achieve that kind of speed? It sounds almost too good to be true.
The secret sauce is abstraction. Instead of trying to simulate every tiny detail of the physical world, Fleet2D focuses on what really matters for high-level robot behavior.
Okay, can you break that down for me? I like to keep things simple.
Imagine you're teaching a robot to navigate your home. Instead of simulating every tiny detail like the texture of your carpet or the exact pattern on your curtains, we can simplify things by focusing on the key elements: walls, furniture, and open spaces. This simplification allows us to run simulations much faster without sacrificing accuracy in the robot's learning process.
So it's like creating a blueprint of the home instead of a high-definition photorealistic model. Smart.
Precisely. And Fleet2D takes this simplification even further by working in a 2D world. This might seem counterintuitive, but it actually makes the simulation much more efficient, without losing the essential elements of the home environment.
So instead of getting bogged down in all these complex 3D calculations, Fleet2D streamlines things by working with a 2D representation. I'm starting to see how they achieve that impressive speed.
Right. And there's another clever trick up Fleet2D's sleeve: caching. It pre-calculates things like visibility within the home layout. For example, if the robot knows there's usually a coffee table in front of the sofa, it doesn't need to re-see it every time it moves around. This kind of pre-calculation saves a ton of processing time, making the simulation even faster.
So it's like giving the robot a cheat sheet for its surroundings. I like it. It sounds like they've put a lot of thought into optimizing for speed.
Absolutely. Now, to really see the power of Fleet2D, let's dive into some concrete examples of how researchers are using it.
Okay, so we've talked about why Fleet2D is so fast. But how are researchers actually using it? What kind of robot behaviors are they testing with this simulator?
Well, one exciting area is prototyping. Imagine you're designing a robot that helps with chores around the house. You could use Fleet2D to rapidly test different behaviors, like how the robot prioritizes tasks, or how it navigates around obstacles, or even how it interacts with people.
So instead of building a bunch of physical prototypes and running time-consuming real-world tests, researchers can use Fleet2D to quickly try out different ideas and see what works best in a simulated environment.
Exactly. And because Fleet2D is so fast, you can run hundreds or even thousands of simulations in the time it would take to conduct a single real-world test. This allows researchers to explore a much wider range of possibilities and fine-tune their robot's behaviors before ever setting it loose in a real home.
That makes a lot of sense. It's like having a virtual testing ground for your robot's brain. Are there other ways researchers are using Fleet2D?
Absolutely. Another important application is data generation. As you know, training AI models for robots requires massive amounts of data. Fleet2D can generate realistic and diverse scenarios that can be used to train these models.
So instead of sending robots out into the real world to collect data, which can be expensive and time-consuming, researchers can use Fleet2D to create a sort of a virtual training camp for their robot's AI.
That's a great way to put it. And by simulating a wide range of situations, including things like different home layouts, human behaviors, and even unexpected events, researchers can ensure that their robots are prepared for the complexities of the real world.
It sounds like Fleet2D is a real game changer for AI development in robotics.
It really is. And there's one more use case I want to mention. which is particularly relevant for ensuring the safety and reliability of robots in home environments.
Okay, tell me more. I'm all about robots that are both helpful and safe.
Well, think about all the things that could go wrong when a robot is operating in a home. It could bump into furniture, knock something over, or even get in the way of people.
Oh, I've definitely tripped over my fair share of robot vacuums.
Right. And these kinds of incidents can not only be inconvenient,
Yeah.
but also potentially dangerous. That's where Fleet2D's ability to run long-term simulations becomes really valuable. Researchers can use it to simulate weeks or months of robot activity in a virtual home, testing different safety protocols, and identifying potential hazards before the robot ever interacts with a real person.
So it's like a virtual crash test for home robots. But instead of testing for physical impacts, we're testing for potential behavioral issues. That's pretty brilliant.
It is, and because Fleet2D is so fast, researchers can run these simulations with a wide range of parameters, trying out different safety algorithms, and seeing how the robot performs in a variety of situations. This kind of rigorous testing is essential for building robots that we can trust to share our homes with.
I'm really impressed with the versatility of Fleet2D. It sounds like it has the potential to accelerate the development of home robotics in so many ways.
I agree. And there's another aspect of Fleet2D that I think you'll find interesting. Remember how we talked about abstraction and how it simplifies the simulation? Well, it turns out that Fleet2D can also incorporate real-world data into its simulations.
Hold on, I thought we were simplifying things. How do we go from a simplified 2D world to incorporating real-world data?
That's a great question. Imagine your robot has already explored your home and created a map of the floor plan. Fleet2D can actually take that real-world data and integrate it into the simulation.
So instead of starting from scratch with a generic home layout, we can use the robot's own map as the foundation for the simulation. That's pretty cool. What are the benefits of doing that?
Well, for one thing, it makes the simulation even more realistic. The robot is essentially practicing in a virtual replica of its actual environment. This can be especially helpful for testing behaviors that are highly dependent on the specific layout of a home.
I see. So if you're testing a cleaning robot, for example, using a real-world floor plan would allow you to see how it navigates around your specific furniture arrangement or finds its way back to its charging station.
Exactly. It's a powerful way to combine the benefits of simulation with the accuracy of real-world data.
This is blowing my mind. Fleet2D is so much more than just a simple simulator. It's a sophisticated tool that can adapt to different needs and levels of complexity.
Absolutely. And it's designed to be flexible and customizable. Remember when we talked about the modular architecture? Well, that modularity extends to the way you interact with the simulator itself.
Okay, now we're getting into the nitty-gritty. Tell me more about this modular design and how it works.
Think of it like building with Legos. You have different components or modules that you can put together in various ways to create different structures. In Fleet2D, those modules include things like floor plans, entities which represent robots and humans, algorithms for controlling behavior, and metrics for evaluating performance.
So instead of being stuck with a fixed set of options, researchers can mix and match these modules to create custom simulations that are tailored to their specific needs. That's awesome.
It is. And this flexibility is one of the key reasons why Fleet2D is such a powerful tool for research and development. It allows researchers to explore a wide range of ideas without being limited by the constraints of the simulator itself.
This deep dive has been a real eye-opener. I'm so impressed with the thought and innovation that has gone into Fleet2D. But before we get too carried away, I have to ask the million-dollar question. How does Fleet2D stack up against the competition? All right, let's get down to it. How does Fleet2D actually perform compared to other simulators out there? I'm thinking of the big names like Gazebo and Weebots.
Well, the researchers behind Fleet2D did a very thorough comparison. And the results are honestly remarkable, especially when you look at simulations that run for longer periods, like 48 hours or more. Fleet2D just blows the competition out of the water when it comes to speed.
Wow, that's a bold claim. Are we talking like twice as fast? Or is this something more dramatic?
Oh, it's way more dramatic than that. We're talking orders of magnitude faster. It's like comparing a leisurely stroll to a rocket launch.
Okay, color me impressed. But speed isn't everything. What about accessibility? I mean, some of these simulators require some serious computing power. Does Fleet2D need a supercomputer to run?
That's another area where Fleet2D shines. It's designed to be very resource efficient and runs smoothly on a standard CPU. You don't need a fancy, expensive GPU to get great performance.
So researchers and developers can run large-scale simulations without breaking the bank on hardware. That's a huge win for accessibility.
Exactly. And it means you can run multiple simulations in parallel, which
Mm.
is really helpful for rapid prototyping and testing different ideas quickly.
Okay, so we've covered the why, the how, and the wow factor of Fleet2D. It really does sound like a game changer for home robotics. But now I want to hear from our listeners. Imagine you have access to this incredible tool. What kind of robot behaviors would you want to simulate and test?
That's a great question. It really sparks the imagination. Think about the possibilities. A robot that not only learns your cleaning preferences, but actually anticipates your needs based on your schedule and habits.
Or a robot that acts as a personalized tutor for your kids, adapting to their learning styles and helping them grasp challenging concepts in a fun and engaging way.
Exactly. Or even a robot that assists elderly family members, providing companionship, monitoring their health, and helping them maintain their independence.
The possibilities are truly endless, and what's so exciting is that Fleet2D makes these possibilities more attainable than ever before.
It's really democratizing access to cutting-edge robotics technology. And with its open-source nature, anyone with the passion and curiosity can contribute to its development.
That's what I love about this field. It's constantly evolving, and tools like Fleet2D are empowering a new generation of innovators to push the boundaries of what's possible.
It makes you wonder, doesn't it? Will this lead to a future where robots are seamlessly integrated into our lives, not just as gadgets, but as helpful companions?
Robots that can learn, adapt, and truly enrich our homes and families. That's a future I'm excited to be a part of.
Me too.
Hmm.
And I have a feeling that Fleet2D will play a key role in shaping that future.
Well, folks, there you have it. Our deep dive into Fleet2D. We've explored its speed, its versatility, its impact on AI development, and its potential to transform the world of home robotics.
It's been a fascinating journey.
It really has, and we hope it's sparked your own curiosity and given you some food for thought. So go out there, explore the world of robotics, and maybe even give Fleet2D a try yourself. Who knows, you might be the one to create the next generation of amazing home robots.
Thanks for joining us on this deep dive.
Until next time, keep exploring.